So this is the first of a couple of live meetings that we're going to be having, and the goal at the end of, let's say, sometime before the last Saturday of March is that we would have built like a decent app. But we're going to start very, very slowly, right? I'll be sending other materials for you guys to go through, like basically that covers the fundamentals of that and documenting different widgets. But we're just going to start here with the basics first. The reason why we're starting with the basics is because it's one thing for you to be able to learn how to code and program, and it's another thing for you to know how the underlying technology works, right? So let's get started. This is introduction to Flutter, the bits and pieces. And so the first question obviously will be, what is Flutter, right? So Flutter is a Dart-based open source framework by Google for building beautiful user interfaces, natively compiled applications, and applications that run on multiple platforms with a single code base, right? So everything there is beautiful, but trust me, when it comes to people looking to employ you, right? One of the key things they look for is just managing one code base. If my application does not require native functionality, let me just hire one set of developers that uses one framework to build this application that runs on different types of devices. So it runs on mobile, Android and iOS, web, desktop, and embedded computers. So one of the reasons why I mentioned that, even though it's not here written right, is because Flutter itself is written in Dart. So if you have any familiarity with frameworks like ASP.NET, Laravel, and so on, the framework itself is not a language. So Flutter is not a language, right? The Flutter itself is a framework that sits on top of a programming language. In this case, Dart. So that's why it will be good for you to sharpen your Dart skills moving forward. So beautiful user interfaces. I don't have to tell you what that is, right? The nicer your application looks, the better the experience, and the longer people tend to use your apps. They're natively compiled. So now native compilation means it's going to build the application and execute it on the operating system as if you built it natively. So Android apps are built natively using Java or Kotlin, right? Or a combination of the two. So Flutter is going to build it as if it was built natively, which makes it run faster. So I've already explained what multi-platform is. Now let's talk about the Flutter architecture. So this is the Flutter architecture, right? So the Flutter itself is a framework. As you can see here, is Dart based, right? It's a Dart based framework, and you have um, two major components that are at the top of the stack, right? So you have Material. So Material is Google's own design library. Then you have Cupertino, which is iOS, right? If you build using Material and you launch on iOS, it will still run. But if you want to give it more of an iOS look, right, you end up using more of the Cupertino design elements or elements within the Cupertino library. Now you have widgets. So everything within Flutter is considered a widget, right? So your button is a widget, your text is a widget, everything is a widget. That's actually a saying in the Flutter community that everything is a widget. We have the rendering in between. We have animation, painting, gestures for your on-click listeners. We have the whole Flutter Framework Foundation at the bottom, which is what supports everything. So if you notice below that, right, we have Dart as a programming language for the framework. Then we have C++ as as an engine behind. That's because most operating systems are built using C and C++. Then below that, now we have more platform specific components. So this is at this stage now you're doing embedded computing. So you're dealing with native packages, thread, and event looping and so on. So this is the Flutter um, architecture in a nutshell. And what we are really concerned about right now is at this top stage. So you should know that, okay, if I'm building a Flutter app, I'm either using the material library or the Cupertino library, and and my widgets are going to represent whatever design guide I have. So if I'm designing for iOS, I'm going to use the Cupertino library. If I'm using material design, that means it's going to have more of an Android, right? So I have the links to all this stuff here if you want to see, gain more information about it. So now Flutter Fast and Flutter Native, right? Thing is, Flutter has two compilers, right? Two sets of compilers for two different reasons. One helps in your development, and the other one helps in building your application in a running environment, right? So when you are developing, you want your application to be built as fast as possible. You don't want to run an application then or be writing your code, then it takes it like 5 minutes for you to see the changes or to rerun the entire app before you see the changes. Sometimes maybe you just change like a small text, then it's going to take a whole build again for you to see it. So Flutter allows you to do what is called hot reload. So we have two sets. So we have the compiler for development, right? Then we have the deployment based compiler, which builds native versions of your application. So the development based compiler is called JIT, or just in time compiler, right? So when you are developing or you save or you hit or you press R when you are building a Flutter app, it's going to hot reload the app, and that is now going to show you the recent changes. So as I'm doing this, this is the problem when people start coming in late. I have to be going to admit new people. So the just-in-time compiler is used during development. It gives you your changes in almost real time as you're making the changes, and you save or you hot reload. It's going to reflect those changes to you. Then we have AOT, right? So this AOT now is not Attack on Titan, right? It's um, ahead of time compiler. So it builds the native version of your application, which runs on x86 or ARM processors, which are basically both desktop based processors. So I have the notes here saying Flutter just in time compiler updates the changes during development to new changes as they are made. So you can see this guy building his own, like doing some form of construction, and the changes are happening real time. Then we have the ahead of time compiler. So it builds native applications for the desired operating system. So it makes it run very fast on that operating system. So this is one difference between a framework like Flutter and a framework like React. While Flutter is going to give you a native application, React is not going to do the same, which makes Flutter apps run uh, faster. So now I've mentioned the word widgets, and I told you that everything in Flutter is considered a widget, right? So basically, widgets are just visual components that represent their current configuration and state. So this word state here should be something that is at the back of your mind when you are building Flutter apps or even React. So you have to be managing the state. So if you look at the illustration at the side, let me look for a typical example. If you go to Amazon, right, and you add an item to cart, automatically you notice, or even Jumia or Konga, you notice that the content in the cart, if it was empty, you have maybe like one item showing you that you added one item to the cart, right? That means the state of that cart widget, using widget now since we're talking Flutter, the state of that widget, that cart widget has changed from having nothing to having one. If you add the second item, it will now update again. So your widget describes the view that should look like the given configuration and state of that particular widget. So everything in Flutter is a widget. So basically, you want a situation where if you click a button, right, the widget itself will respond because its configuration has changed. It's been pressed. So it should show that, okay, this button has been pressed. Then when they release the button, it should go back to the default state again to show that the button has been released. If an action has been sent, it should now trigger that action and perform the necessary changes to any other widget. So if you look at this illustration, once we click on add here, it now goes and says, okay, an item, the second item, tells the cat updates its own UI to show that, okay, this particular item or an item has been added to cart. That's just basically what this is in a nutshell. So everything you see and you interact with in Flutter is a widget. We're going to see that shortly. So now we have two types of widgets, right? We have stateless and stateful widgets. So like I said, state is very, very important in Flutter, right? So you have to be managing the states of the widget to say when something changes, this is what this element should look like, and so on. So, but we have widgets that don't change, right? So widgets that don't change, like let's say the title of your application, right? Or the name of a button. Let's say button's name now is login. It doesn't change. So there's no need for you to manage the state of that particular element because it doesn't change. So those are what we call stateless widgets. Right? They don't change. They just remain the same. Mainly used for decorative purposes, right? So if you want your application to always look a certain way, then most of the design elements they will be stateless widgets. Then we have what is called stateful widgets, which is on this side. So stateful widgets change to reflect the change in configuration of that particular widget, right? So when you click a button, right, for an action to happen, it has to interact with a stateful widget. So you're going to update the state of that particular widget, be it the button or another supporting element, right? You're now going to trigger that particular element to start the update process. So the flow is this. So we have a constructor, right, that basically initializes the widget. Now, when a widget is created, we create this create state function is called. You don't see this, right? You just use your widgets, but you don't get to call this yourself. But the create state basically creates the widget itself, right? So the widget exists, but it's not visible yet. Then we have the init state. So the init state basically adds the widget to our widget tree. So there's something called the widget tree, right? When you are building an application, so let's go back here. So let's say we have this login screen. So this login screen, let's assume or this app, let's assume the whole app is a material app instead of a Cupertino app, right? So within this now we have the material app. We have the root of the app, then we have the material app, then we have all these login components within our um, widget tree. So when the init state is called, after it has been created, then we now move to adding the widget to our widget tree in the init state. And finally, the widget is now built. So once the widget is built, it now becomes stateless because obviously you've made your changes, right? Or the widget has been built. At that current state, it remains stateless. So now this set state updates the component within the widget. So if you click a button, if you call set state, it's now going to update every other element that is tied to whatever action that button performs and updates them. So instead of you updating the entire screen, you can just update what requires. It just updates what requires the changed data and reflect the um, new added information. Now this did update widget. Now what it does is, let's say your application is put in the background, right? The operating system itself can just decide, you know what, this application is using too much memory. let me change the configuration of the system to prioritize something else, right? Application gets frozen, this itself is now going to reflect those changes. So if you make those changes, right, and you bring an application to the foreground again from the background to the foreground, automatically that application gets built again with the new configuration. That's what this does. But the most important thing you should know here is that there are two types of widgets. There are stateless widgets, which don't change and remain constant through the lifetime of the application. Then you have stateful widgets, which change to reflect change in data or configuration of that particular widget. So, getting ready for the hands-on session, but these are some of the common widgets you are going to see. Of course, these are not just the most common one. There are things like text fields and so on. But for getting used to how the design process of Flutter is, you have to learn things like scaffold, container, column, rows, safe area, and so on. So let me pause here first for your question. So if you have a question, you can just unmute yourself before we go to coding session. Is there anyone with a question? So guessing none of you wants to ask any question. Maybe you ask questions during this during the coding session. But now so let me open this. So if you've created a Flutter project before, this is what you are going to have, right? You have the default application. So I have mine running on an iOS emulator, iPhone 14 Pro Max. I wish it was this easy to get this phone, right? Um, so let's talk about some of the things on this side, right? So we have a couple of folders here. Whenever you create the Flutter application, so we have the Android project here and we have the iOS project here. So subsequently, we are going to be going into more detail describing how to make some Android specific changes here because let's say you want to use the camera or GPS of the device, you have to make some changes to the Android application manifest, which we are going to discuss at a later date. Then same thing with iOS. So these are the folders for Android, iOS, and in this case, I didn't create for Mac and Windows. So there's no Mac and Windows folder here, but we have a Linux based operating system folder here. Then right now, the key thing I'm going to discuss is this pop spec um, YAML. So this basically holds like some of the specifications and tools and libraries that your project is going to depend on. Um, sorry for that pun. We have dependencies here. So let's say if you're going to make internet calls, you may need to add the HTTP library here. You need to add dependencies here. So also, if you want to add default images to your project, right? You have to use this part of the um, obspec.yaml. So I'm not going to do that today, but subsequently we're going to do that where you create a folder. You have to create an assets folder. Then within the assets folder, you need to have images, then the name of the image, right? So this hash you are seeing here is just comments. So you have to uncomment this. So just like Python, this is I think the better way to say this is indentation sensitive. So it's sensitive to how much indentation you have. So everything has to be properly indented. So we have this flutter here. Then the next stage is this indentation, two spaces or a tab, right? So it Take note of that. Then also, your application does not have the same font as this. You can always change the font of your application. So you can go online to different websites. Like I think Google has a website for fonts. Get free fonts there and add them. So just like the app, the images, right? You can just you create a fonts folder, add the font. Then you can now specify that okay within the font folder we have this particular font, and fonts are in .ttf format. I think that's just basically it here. So the dependencies that your application needs are going to be within this. Subsequent meetings, we are going to actually use dependencies. Then, if you have dependencies that are just used for development, right? Yeah, it's not going to be part of the application that you publish. Then they are going to fall under dev dependencies or dependencies. Now, another thing I want to discuss is the test, right? So, currently there's a whole trend of test-driven development. We have like a separate section on that. But it's good for you guys to get familiar with the whole process because right now you write your application test first before you even write the features to make sure that okay, this particular function does what I want it to do before I actually build the whole project around that. So we're going to discuss that. Now to add, there's probably something that I may not have the time to cover during this whole process. It's your use of Git and GitHub. So I advise you guys to just learn how to use GitHub. Not just to add, commit, and push, right? But to branch, to create branches. So you can create a by default you have your main branch, right? So you can create a dev branch, then you can subsequently create feature branches from there. So now let's just come back to main.dat file and analyze this file. So one issue I have with this file is the fact that it has a lot of comments in it. So we're just going to ignore the comments. So this is our main function. It returns void and it's what initializes our app. This is what launches our app, right? Just like your main function in C++, Java, and so on. The main function is the main point of entry to the application. So now at this stage, we have our stateless widget. So I'm trying to see where it starts. We have our stateless widget here like this. So I'm saying our class extends a stateless widget, right? So if you remember from this sketch, whenever it's built, it now returns to the stateless widget to build stateless version of our application, right? That's why we are extending stateless widget here. So we have our stateless widget, and we have the build function from that same diagram. So now remember, our app can either be Material or Cupertino. So in this case now, we are returning Material app, right? That's why we have this. These are some certain features within it. I'm going to clean all this and we're going to build something very, very simple. So within this Material app, it expects a title, a theme. So theming is a separate topic in Flutter, which we'll take our time later to discuss. We have it requires a home. So the home now is basically what you see here on your screen, right? So now the home now, because if you click this button, this value changes. The home has to be a stateful widget because the content here changes whenever I click this button. So that's why we have class my home page extends stateful widget, right? So basically, this extends a stateful widget, which means state itself changes. So let's see where the state change is done. I'm not going to explain all this, but right now because what we're just going to deal with is stateless widgets first. But let's just get the roundup of it. So whenever you click this button, right, this method is called, or this function increment counter. So let's scroll down to see where it is. the floating action button. What does it do? It calls this function when it's pressed. So automatically, we have this set state method. So if you remember, the set state method um, updates the widget that depends on this particular variable, right? And so when this variable changes, that particular widget is updated. We have our dependent variable here, which is the text, text. So that's just basically the roundup of how this thing works. So you have the application itself being a stateless widget, but we have some stateful components, which is why this has to extend. So for those of you who have not who have not written Java before, extends is just the word that represents inheritance, right? So you've not written, if you're not familiar with Dart and Java, extend just means inherit from the stateful library. Just like this one inherits from the stateless widget. So this now makes it stateful, and we can set the state whenever everything changes. So like I said, for today, we're not going to be using we're going to be using stateful widgets. So I'm just going to press this and delete. So hopefully I have what reload. Let me change this now to, let me just return let's say scaffold. Now we have an empty project, right? We have this empty project here. So within this empty project, what I can do now is I can have so one trick I'm going to show you guys is whenever you hover over a widget, right, it's going to show you some of the components that you can use. So just read what's on the right side. So we have body, we have app bar, and so on, right? So now let's create an app bar, right? So to create an app bar, it's just this. Because if you notice, our application does not have a bar. So I can now add a title to the app bar. So my title is going to be text. So say GDSC. So if I refresh this, you can see that it has automatically hot reloaded and added the changes to the application. So I can add background color. Someone should give me a color. What color should we use?
Orange.
Add orange. Add orange. So let's use orange, right? So automatically our application changes. So the reason why we're having this warning here, this doesn't really matter what it's telling us that since this doesn't change, right? Since the text doesn't change, it's a static hard-coded text, right? You can just declare this here as constant, right? This other one is because GDSC is not a recognized word. That's what we have here. So apart from the app bar, we also have outside the app bar now. So this is where our app bar starts. This is where it ends. So outside the app bar, I'm now going to create body, right? So now our body now can be a any layout based widget. So a layout based widget can be your container, can be your column, can be your row, and so on. So now let's use a container, right? So if we have this container, I can now say the color of the container is orange. Colors dot orange. Let say orange accent. If you notice now we have our container filling out the entire layout, right? So let's add something else. So how do we add another component into this container? The container here has what is called a child widget, right? So always take note of this child widget, right? So this child widget means you can add another widget under this widget. I'm just going to add this again as an attribute, child. So within this child now, what I want is a column. So who can tell me what a column is? A column is just a layout component that arranges things from top downwards, right? Um, top to bottom, vertical arrangement. So the counterpart to this is row, which is left to right. Now we can now add children to this column. So unlike container that takes one child, right? Your column takes multiple children. So you can add many things into this column as long as it fits within the size of this particular column, right? So let me create some other helper variables. I'll just delete all this. I just want to create some things that I'm going to reuse later. So I'll create double say device with. So basically what this does is it gets the current device width for me, right? So I'm trying to get the current device width so that my elements do not overflow outside the size of the device. That's why I'm creating this. So I'm going to say device height. I'm going to change this to height. So this is also going to return the height of the device. The reason why you do this is because all devices don't have the same height, right? So you have to manage the device width and the device height. So I'm using this so that my components don't overflow out of the size of the device. So let's create a container. Another container now inside. So this container is going to hold, let's say, a profile. So I can say decoration. So decoration just allows you modify the shape and the look of this particular container. So I'm now going to set the shape to be, let me just remove this first. So image, call the decoration image component. What this does is it gets us an image, right? So I'm using network image, which means I can just pull an image from the internet and play it. So there's this website called Pravata, right? So I'm just going to let me just copy a random image from this Pravata. I'll add this. So let me get our emulator back up. So let me see what error we have here. Media, blah, blah, blah. Let me just comment. Let me comment these two out first. So we have that. So let me just take those two out because probably using the wrong library. So now we have this right, and right now it's not showing anything. So what I can just do is I can just say height is equal to, let's say, 200. We have our image now showing. So this is just a random image pulled from the internet. So using the decoration, right, I can actually change what shape this is. Right. So if I want to do, I can now add the shape attribute and say shape circle. If I refresh this now, we have this circular shape to our image, right? So you can always mess around with some of this stuff, right? So once we are done with our image, we can now go to let's create a text form field. So let's say form field. So this is just basically your input text, right? So if you click it, you need to paste information. So this also accepts a form of decoration. So let me add a decoration to this. But the type of decoration now is input decoration. So I'm just going to create a constant decoration and have the hint text. So this will just allow us to have a hint to it, right? So I can now say email. If I refresh this, I have email here, email text. So if you want to change what this looks like, you can now add what is called the hint style. So this is text style. Just a color, colors the white. You want to make it italicized and so on. You can do that. So we have this text widget, right? This text form field. If we want to add one for our password, let's say we want to create a password, just put asterisk here. Then now there is a property called obscure because we want to obscure the password text. Right? So obscure text now, you can now set it to true. Type anything here. If you notice, the text is obscured. Well, this one is not obscured. So looking at this now, you can see, excuse me, you notice we have these things going edge to edge, which means we need some form of padding. It's always good for you to have like padding around your components. We're now going to add padding to the original container. So you can say padding, then it's going to be constant. So the padding is now added using this edge. It sets sets say all. Spelling something. Sets. So now we have some form of padding. You can make this 20 if you like. It's now going to give us more space around these components. So also, if you look at this stuff, they are very, very close to each other, right? So that's because we did not add some form of arrangement to our column. As a matter of fact, I wanted to make this part like a separate part for you guys to understand. So the column has some properties here. You can see called the main axis alignment, main axis size, and also the cross axis alignment. So in a column, the main axis of a column is vertical. So the main axis of a column is vertical, right? Then the cross axis is horizontal. So using this logic now, if you are going to think of a row, right, a row is going to be the other way around. The main axis for a row is is horizontal, left to right, while the cross axis is vertical, top bottom, right? So that's what I wanted to just make clear. So now I'm now going to set the main axis alignment. So let me see, main axis alignment dot space evenly. So let's use space evenly and see what it gives us. So if you notice now, space evenly has given us enough space between the top and back and this image icon and this one and the next one and so on. So it creates even space around them. So you can use space around, or you can try space between. Space between, if you notice, you just created spaces between each of them and just left it at that. So the more components you have, the more it shrinks. So let me just show you how that will look like if I add another component here. If you notice, it's shrinking, right? But for me, I think I prefer the space evenly right now. So that's just what this looks like at this moment. You can add cross-axis alignment and so on. I don't think we need that for this. So let's add a button. So I'm just going to create a material button, and this button does not do anything when pressed. So empty. So add the color. So colors. Let me use this now so that we can see our button. So we have an indigo colored button, right? So you can also add. It also has a child. So our child now is going to be text. So our child is going to be text. I can now say login. So let me throw this question to you guys now. What is wrong with our button right now, design wise? You can tell me what you want to change about this button. Yes, Kelvin.
Color of the button.
What color?
It doesn't choose the color of the background.
Okay. I think Daniel also wanted to talk. What was your own change? Yes, the color of the button text, right? So I understand why you said the color of the button does not look nice. But right now, I think the most obscure thing in this design is the color of the text, right? So we can now add a style to this and say our style is going to be of type text style. And you can say color is colors dot white, right? So if you do this automatically, it kind of looks better, right? If you want to change this now to match the color of the blue theme now, you can do that. But the whole idea here is be able to know how to arrange some of these components. So what I'll just do now is I'm going to add a row so that we see what a row looks like. So let me add a row. So for this row, I'm just going to create add its children. Children is just going to be create empty container. Set the color to just the colors black 12. Now we've added them, but we can't see them because they basically have no size. So I'm going to add height to them. Let me add a width first. Width 50, height should be. So I'll copy these properties here. So now you notice that our containers are joined together. So how do we fix this if we don't want them to be clustered together like this? Wants to give us an idea. Nobody. So basically what we need to do is to add an alignment, right? So say main axis alignment. So you can say main axis space between. So you notice it pushes them to the edge. So just the same thing with the what they call it with the column. But in this case, if you notice, instead of it going top downwards vertically, the main axis is now left to right. It's now horizontal. So this is just supposed to be like a rundown of how the design system is. You are going to um, let me even explain some certain things like this scaffold. What this scaffold does is it provides some basic components that you need for your application, right? So the scaffold is what gave us this app bar. If we don't have this scaffold, we can have our app top here being blank. So it gives us the basics to scaffold our app or to bootstrap our app very, very fast. So we have the app bar that it gives us. It has so the app bar now, if you're going to relate it to HTML, it's going to be like the head section. So now the title is just like the title in your app. Then you have the body section that has everything. So since we have this to show you another feature that the scaffold adds, let me just come before the body. It's supposed to be at the bottom. We have a bottom navigation bar. So to take bottom navigation bar widget, it has a list of items. This let me see where we are getting this error from. Okay, I think we need to add a label. So this label is going to be home. This label is going to be work. This label is going to be play. So notice how fast with a scaffold we can create stuff like this, right? So if you are building something like the whole Instagram design system, I think they use it for implementing the click functionality of this. This is going to be important in our subsequent videos, and you can always redesign all these components. It doesn't have to look like this, right? This is just me trying to show you as much things as I can. So I can change this back to, for example, to white. It kind of looks different, but you can play around with all these things. So the idea is the scaffold provides you the app bar, body, and if you're going to use the navigation bar, you can also use this. So I don't know if you have. Let me just stop here now for questions because we have 5 minutes. I'm recording this video, so I'll still share it guys, for people that still want to watch, because subsequently the project we are going to be building, the idea is at least before March, everybody in this group should have to their credit at least that we built one app under the DSC. That's the goal. So by the end of March, we should be looking towards us finishing a project. But the project may require more time on our behalf. But right now, we're going to be going Fridays. Then, apart from Fridays, I may send videos, links in between for people to try out certain stuff before we continue. So, I don't know if you guys have any question regarding this. General questions now. Yes, Daniel.
Okay, good afternoon.
Good afternoon.
I wanted to ask if the video could be made available to stay offline, so we could go through it maybe once more.
Yes, I'm recording this right now, so I'm going to share the video. I don't know what you mean offline, Cha. I'm going to share it. If you want to download it, fine. But
Okay, yes, the download.
so you can download it if you want. But I'm going to share the video with you guys.
All right. And can you also recommend some videos for us to go through? So
Yes,
by the
I'm
next
going.
time we should have understanding.
Yes, by Monday, I should be able to send you guys some other content for you guys to check out. Let's say YouTube videos and so on. For you guys to get started with. But the most important thing to me right now is the knowledge of that. Just practice that. Go to datpad.dev and just practice some of those things. I'm going to show you. I'm going to send you some stuff to guide you on the key things that we can use to get started before you continue your own journey on getting much better with that. Um, Kelvin, your hand was up. I don't know if you still, but you put it down.
Yeah, so Daniel has already said what I wanted to ask.
Okay, all right. So I don't know. I don't know if everybody here is on the Slack, group, right? If you are here and you're not on the Slack, please let me know. You can just type it. You can just type your email in the chat. Then I'll invite you. Yes, Daniel, the other Daniel. Yeah, I think maybe it was regarding the Slack group. Okay, just type your email within the chat, and I'll take that. So I hope everybody enjoyed this. The whole idea behind this particular session is not for you to build what I just did right now, right? It's mainly for you to even understand the um, basic building blocks of Flutter. So you understand that there are widgets, there are stateful and there are stateless widgets. We have to manage the state of these widgets. There are state management packages that we're going to discuss later on. But right now, we're just going to be settling with set state first. Then subsequently, we can now move to adding um, stuff. But so I'm going to open it on the Slack now. If you guys have any idea on what project you guys want us to do, I have my own idea in mind. But let me just see if you guys can come up with something better. Not something too big, but something in between that can test that requires like the internet integration with an API and stuff like that. Something that we can build using Firebase. So if there are no further questions, or if you think of questions later, you can ask in Slack.